Good morning, friends. Today we will start with the problems on bolted connection. For that, we must know the design steps of bolted connections. So, in that, first we start with analysis and design of bolted joints for axially loaded plate, single and double angle members. See here, we are going to start for type 1 problems. In that we have to analyze and design of bolted joints for axially means the load passing through the center of gravity of the plate section, loaded plate, single and double angle members. Here we are going to use single or double angle members. So in that we will start with step 1, that is we have to calculate strength of bolt in shearing. See here, when we are going to design a bolted connection, in that design means we have to find the number of bolts required for the given load condition. So while designing any bolted connection, we have to consider the load given on the bolted connections. For that, when we are going to apply the load on the bolted connections, then there are two forces are acting on the plates, and these forces are also known as strength, and these strengths are in shearing or it may be in bearing. So we have to calculate the strength of bolt in shearing and bolt of strength in bearing. So in first step we are going to calculate the strength of bolt in shearing as VDSB. This is the standard notation for calculation of shearing strength in bolt, where VDSB represents VDSB designed, D for designed, shear strength, S for shear strength, B for bolt. Designed shear strength in bolt is given by FUB upon root 3 into gamma MB into bracket NN ANB plus NS into ASB. Here FUB means ultimate stress in bolt. See here, F, we know that in strength of materials or mechanics of structure there is one formula, that is M upon Y is equal to F upon Y is equal to E by Y. Here F is the stress. Similarly here F is again a stress, U for ultimate, B for bolt. That is ultimate stress in bolt is taken as for bolt grade 4.6. Suppose in the problem we are given the bolt grade as 4.6. Then ultimate stress in bolt is given by FUB is given by FUB is equal to 4.6. In that, before integer you take 4 into 100. In theory lecture we have seen this 1/100th of the strength is taken for the bolt grade, that is FUB, you 4 into 100, that is 400 Newton per mm square is the stress, ultimate stress in the bolt for a bolt grade of 4.6. Similarly, suppose in the problem we are given a bolt grade of 5.6. Then FUB is 5 into 10, 5 into 100, that is 500 Newton per mm square is the stress for a bolt grade of 5.6. Similarly, the yield stress in bolt is calculated after integer, that is 0.6 and 0.6. That 0.6 is considered to calculate the yield stress, that is FYB. F for stress, Y yield, B for bolt. Yield stress in bolt for 4.6 grade is 400, that is ultimate stress in bolt, into 0.6, that is 240 Newton per mm square is the yield stress in bolt. Similarly, for 5.6 grade, FYB is equal to 500 into 0.6, that is 300 Newton per mm square. These values are required while solving the problems. So you must remember this. That is for grade 4.6, the FUB is equal to 4 into 100, that is 400 Newton per mm square is considered while solving the problems. Then gamma M1. Gamma M1 is nothing but it is the partial safety factor and it is taken as 1.25. Then in that formula, Nn is given, that Nn is nothing but these are the number of shear plates with threads intercepting the shear plane. See here, Nn is nothing but number of shear plates with threads. Here all these problems we are going to use the plates or bolts with threads. So always Nn for single shear is taken as 1. So remember this one, and we are going to use all threads. So there are threads, whenever there are threads are given or not given, we are going to use Nn as 1. Then Ns, number of shear planes without threads. Without threads we are not going to use in these problems. So Ns is always taken as equal to 0. Then ASB is the nominal plane shank area of bolt. That is when the bolt is plain, there is no threads. At that time ASB is considered nominal plane shank area of bolt. And ANB is the net shear area of bolt at threads. That is net area and gross area. These are different terms, we will see afterwards. Then step 2, calculate strength of bolt in bearing. First we have calculated the strength of bolt in shearing. Now we are going to calculate strength of bolt in bearing in step number 2. This strength of bolt in bearing is calculated by using the formula VDPB. By using the formula VDPB. Again, D is for designed strength of bolt in bearing. B is for bearing, is given by 2.5 kb into Dn into Tp into Fu upon gamma MB, where VDPB is design strength of bolt in bearing. Kb, this Kb is bolt constant and is calculated or taken the minimum of following 4. That is in that first one, Kb is equal to E upon 3D0, where E is the edge distance. See here, two plates are connected to each other. These are the lap joints and two bolts are provided. From one bolt center to the edge of the plate, this distance is known as edge distance. This Kb is minimum of E upon 3D0. That is, E is the edge distance, 3 is the constant, D0 is the hole diameter or gross diameter. This gross diameter is calculated as see here, when in the problem nominal diameter is given. When nominal diameter is given, nominal diameter is nothing but it is the diameter of bolt before bolting. Suppose in market we have purchased a bolt, that diameter is the nominal diameter. When we are going to design, that is we are going to insert this bolt to connect these two plates, at that time the diameter of hole, at that time this diameter of hole somewhat increases. This increased diameter is known as gross diameter or hole diameter, and it is mentioned as D0. So that while bolting, the diameter of bolt is nominal diameter, and after bolting the diameter of bolt is gross diameter. So after bolting we have to calculate the designed load. So for that we are considering the whole diameter, that is gross diameter, and this gross diameter is taken as when we are given the nominal diameter as from 12 to 14 mm. At that time we have to add the clearance, that is the whole size increases, that clearance is added as 1. That is, suppose the nominal diameter is given 12, at that time the whole diameter or gross diameter is taken as dn plus 1, that is 12 plus 1, that is 13 mm is taken as a d0 or whole diameter or gross diameter. Then if the nominal diameter is given from 16 mm to 24 mm, then the gross diameter is taken as dn plus 2, that is 16 plus 2, that is 18 mm is the gross diameter. For dn greater than about 24 mm diameter, that is d0 is dn plus 3 is taken. So remember, when the diameter of bolt is given from 12 to 14 mm, you have to add 1 to calculate the d0 or gross diameter, and when the diameter of bolt is given in between 16 and 24, you have to add 2 mm in that net diameter to get the gross diameter, and when the diameter of bolt is given greater than 24 mm diameter, then you have to add the 3 mm in that nominal diameter to get the gross diameter or diameter of hole. This is very important. So you have to remember all these things. That is, to calculate this bolt constant, we have to calculate the 4 values and in that 4 values we have to consider the minimum of that 4 values. In that, first value is kb is equal to E upon 3d0. In that, E is the edge distance. This edge distance is again taken as shown below. D0, as just we know D0 how we have to calculate. Then edge distance. The edge distance is taken as the minimum. The edge distance is taken minimum, or it should not be less than. It should not be less than 1.5 d0. The edge distance should not be less than 1.5 d0, because as the edge distance is taken after the bolting, so this edge distance is taken minimum of 1.5 d0. See here, edge distance is taken as, where edge distance which is taken as is not less than 1.5 d0, where d0 is the diameter of bolt hole and is taken as that d0, as I have explained all these things. So edge distance should not be less than 1.5 d0, that is diameter of hole. The next, TP is nothing but is the thickness of the plate. Suppose there are two plates which are connected, take the thickness of the plate which is minimum thickness is taken. Then Fu is the ultimate stress in plate. Gamma mb is taken as gamma m1, and that is the partial safety factor, and is equal to 1.25. I'm putting all these values here in this formula. Kb can be calculated as Kb is equal to P upon 3d0 minus 25. That is, P is nothing but it is the pitch, d0 diameter of hole, and minus 25, this is taken as constant. So pitch is taken as, it should not be less than 2.5 dn. It is taken as nominal diameter. So remember, while taking edge distance, we have considered d0. While taking the pitch, we are considered here nominal diameter. It should not be less than 2.5 nominal diameter. This is second value we have to calculate for KB. Then third value is FUB upon FU. FUB is nothing but ultimate stress in bolt, and it is taken from the grade of the bolt, and FU is the ultimate stress in plate. That is, in the problem it is given as plate grade 410 Newton per square. Then you have to consider the FU value 410 Newton per square. Then this ratio is taken as KB, and fourth value is 1. So first we calculate value number 1, KB E upon 3d0. Second value is KB is equal to P upon 3d0 minus 25. Third value is KB is equal to FUB upon FU, and fourth value is 1. Among all these four values, you have to consider the minimum value and calculate the strength of bolt in bearing. Then step 3, bolt value. You have to calculate the bolt value. Bolt value is nothing but it is the minimum value of shearing and bearing strength of bolt. You have calculated the shearing value, you have calculated the bearing value. In that, the minimum value is taken as the bolt value. Bolt value is also known as the strength of bolted connection or load carrying capacity of the bolted connection. So bolt value is nothing but it is the strength of the bolted connection. Then step number 4, calculate number of bolts, and this number of bolts is calculated as number of bolts is equal to load upon BV. That is, in the problem, while you are going to design for certain load, for that load how many number of bolts are required, we have to calculate. For that, take that given load, divide by that bolt value. Bolt value is the minimum of shearing and bearing value. Divide that minimum value and to the load and calculate the number of bolts required. And from that number of bolts required, draw the sketch of that connection. In this type, we are going to start with the problems. So it is very important in the problem solving. That is, you have to go through these steps. That is, in first step, you have to calculate the strength of bolt in shearing by using the formula VDSB is equal to FUB upon root 3 gamma M1 into NN ANB plus NS ASB, where FUB is the ultimate stress in bolt, gamma M1 partial factor safety for ultimate stress, NN number of threads, ANB net area of the bolt. Only this, up to this we have to consider the formula. Here NS, there are threads, no threads, that is, we are not using such type of bolts, so NS is always equal to 0, so this quantity becomes 0. So you only use up to this value, that is NN into NB into FUB upon root 3 gamma M1, and calculate the VDSB, that is the strength of bolt in shearing. From that, you have to calculate the strength of bolt in bearing by using this formula, and here KB is the bolt constant, and this bolt constant is taken minimum of following 4, and that is KB is equal to E upon 3d0. Second one is KB is equal to P upon 3d0 minus 25, and KB is equal to FUB upon FU, and last one is 1. Among these values, calculate the minimum value of KB and consider the minimum as KB and put this value in the above formula. Dn is the nominal diameter given in the problem, Tp is the thickness of the plate which is thinner, Fu is the ultimate stress of plate, and gamma m is the partial factor of safety. From that, calculate VDPB, that is strength of bolt in bearing. Then bolt value, the bolt value is the minimum of shearing and bearing value. From that bolt value, calculate the number of bolts. Number of bolts is given by using the formula given load upon bolt value, and from that number of bolts you draw the sketch. This is the type number 1 problem for 6 marks. So we will start with next lecture with the problems. Thank you.